Thank you very much. I was asked to speak in the microphone, so that's what I'm doing. So my name is Farnaz Sadeghpour. I'm the last author. This is a work that my students have been doing in my lab. And I would love to tell you a little bit about it. As you can tell from the title, this is about helmet detection. This is some of the students in my lab working on this project. Before telling you about the research, I am I studied at Concordia, so this is homecoming for me with Dr. Musali. Right now, I'm at University of Calgary, and we have an amazing research team. I put the website there for you. There is a Center for Project Management Excellence. I would encourage you to go take a look at it. I also want to do a shameless plug-in here. 2027, the conference is coming to Calgary. You should all come. There is Banff, and you're going to love it. It's one of the must-see places in the world. So do take a look at our website. So in a construction site, if you wanted, I want you to try to detect who's wearing a helmet and is not on this video. So this is a typical construction site. People are walking around. Some of them are wearing a helmet, some of them are not. And we know that this is one of the ways of preventing it. It's almost impossible to do it. That's the point that I'm trying to get across by just doing it visually. And this is the reality of how it's happening. So right now, the supervisors are just trying to visually follow who's wearing it and who's not wearing it. And we are here to propose one of the ways of doing it. This clicker is a little bit clunky. Let's see. Okay, there you go. Okay, so a little bit of background for you. In Canada, construction is #1 reason for workplace fatalities. So we divide the industry into 20 sectors in Canada. So construction is about 1/4 of all the fatalities in construction. Every 6 people that die in workplace, one of them is in construction. Let me tell you another thing that's really shocking. We have about, of 365 days of a year, there's what, like 250 of working days if you take the weekends out. We have about that number of fatalities per year in Canada in just construction sites. So 1 person per day dies in construction sites. That's huge. That's heavy. So we need to do things about it. And my research is mainly focusing on that. There you go. So we have proactive approaches. We have reactive approaches. You're all very familiar with that. But one of the reactive approaches, this is not working very smoothly, huh? Okay. It comes, okay. So there's proactive approaches and reactive approaches. So PPE, as we all know, is one of the ways of doing it. It's the last line of defense, and it's one of the most effective ones to okay, maybe I should try using this. All right. Okay. Let's try again. Sorry about that. Okay, so I just told you about what happens in Canada. Around the world, it's not that much different. If you just look at the numbers in UK, same thing, construction among all sectors is still #1. So this is what my research has been about. The non-compliance to PPE is one of the leading causes of injuries. About 60% of people effectively use that. So they either don't, let's say, wear their helmets or they're not wearing it correctly. And also, I want to leave you with this, that 60% of injuries are happening because of not safely wearing helmets. That's huge. So we thought we would like to do something about it, and that's us, our team, wearing the helmets. So the objective of the work that I'm going to present today is about detecting the feasibility of using ultra-wideband tags in detecting whether somebody is wearing a helmet or not. Okay? And I have a few more things to say about this. Okay, before I tell you about that one, so this is the hard hat, and these are the ultra wideband tags for those of you who are not very familiar. So, they are a very small chip that we could put on different places. I would like to tell you, there are existing solutions for it, right? There is manually, visually follow that. There is vision based, so camera based, and then there is the RFID and the Bluetooth tags and things of that sort. And I can talk maybe in the discussion, if you wanted, about advantages and disadvantages of those. However, what we wanted to do is to use ultra wideband tags, and I'm going to tell you why. Well, cameras are very expensive. They're also difficult to calibrate. So from site to site, you need to put them again. And then the RFID tags don't have the same range that we have. So, but there is a different reason. So there is the cost effectiveness. So these chips are $20 per cap. By $20, you could track things with very high precision. So there is the cost. There is the privacy respecting. So you cannot track a lot of things about people the way cameras would. But most importantly, for us, this was a curiosity side project because we use ultra-wideband for proximity warning systems. So the main research that I do, let me tell you a little bit about that so that you know why I was interested in ultra-wideband. So we use ultra-wideband tags to make sure that we predict and prevent accidents, okay? So there's a worker, there is construction equipment that is operational. So if you put tags on things that you want to track, what is that? Human, equipment, and then you put anchors around the site, which is it's like a sticky note, you put them around. The tags will communicate with the anchor, and then with a very precise estimation of centimeter level accuracy, you could track where things are. So what we do in proximity warning systems, this is a general idea, this is not my idea, it's been around for ages. So if a worker is, let's say this is a falling edge of a slab, okay? So unprotected edge of a slab, the worker is moving that way. We usually put some cones or something, say do not go if you're not working on the edge. This is not there is the red zone, basically. Do not go into the red zone. So what we do is that we have those virtual boundaries because we are following things virtually. So when the worker is moving towards that, there would be a warning when they pass that. This is a generic idea. Everybody who develops proximity warning system uses this. What we do is that we use ultra wideband for that, okay? And I've been working on it for the past 15 years. There's so many side projects on it, time latency, location accuracy, the warning system. I work with a group in psychology to see what is the best perception reaction time, what is the best type of signal, so on and so forth. But because we already have that in the work and the construction site, we were curious to see, can we also get a side effect from it and see if they're wearing the helmet or not? You see where I'm coming from? So it was more of a curiosity thing to see, can we take something extra out of that? Okay, there you go. So this is the lab that we work in. This is University of Calgary. So we have a floor that is very carefully, accurately measured, and we have all these measurements on the site. We have a person walking there. We tell them to stop. We, send them an alert, see where they stop. We do all our measurements here. This is the floor map that we are using there, and these are the tags, the ultra-wideband tags that we are using. So yeah, there you go. These are my workers. And these are the 4 positions that we were gonna pilot and see if we could distinguish with the ultra-wideband tag. So there is the standing, wearing, that's one position. There is standing, not wearing. So pay attention to where helmet is, okay? So here, here, and then walking and wearing, and then walking and not wearing. Okay, so for classes. Do you want me to end?
2 minutes.
2 minutes?
Mm-hmm.
I thought, okay. I thought we don't have presenters, so I just was taking my time. We do have the speakers? Oh, so sorry. Okay, so I'm gonna just move faster. Sorry, I thought we don't have the next speakers, and I'm gonna take the whole time of the next session. Okay, so later we added one more class that is seating, because when a person is seating and wearing it, that's very close to where I'm holding it. Okay, so we wanted to see if we could distinguish that, and I can maybe move fast and then tell you about what we did. We also used machine learning with that. But you may ask me why machine learning? Because if I have the XYZ with the location estimation, if I know the difference of the Z, that would be easy. Why do I need machine learning? I want to show you here why I need that. Because if I show you in my 5 classes where the data is, see how close they are. With all the outliers, they're actually very close, the 5 classes of them. Okay, so I did need to do some machine learning. So we started the experiments. I think that's how much I'm going to spend time on it. And then we did some, regular AI classification. So we did the data cleaning. We took out the outliers, as you could see, and then we did some feature engineering here. The computer is slow on animation, so you should give me extra time for that. So yeah, so we looked into feature engineering. We tried it for different time durations, 1 second, 5 second, 10 second. And then we played with different algorithms. We picked 15 of these features, and then we played with the algorithms. Okay, there we go. We tested all these models, and then we identified the one with the best accuracy. So we have the 94% here. These are a little bit, okay. So, and then we also, the pilot that we did, we had 12 people. So we split people, 6 for training, 3 for testing, and 3 for validation. We also repeated that 100 times, and every time we used a different combination of men and women, right? Because I had 3 women and 5 men. We were interested to see if it's different with the way people work with different genders. Okay, so we did some testing, and then we identified the best. We wrote a code in Python. I want to show you the results. There you go. So these are the 4 classes that we have. And, if you're familiar with the true positive and false positive rate, what you do want is the most 90-degree line that you want, okay? So this is pretty good. This is pretty good. And let me tell you what are the identifications that we had done. So if you look at the color code, we have 86% correctness here, 93% here, 91% there, and 97% there. And what is interesting, that's pretty good, right? And what is more interesting is that the bad habits, we were able, so not wearing that, we were able to assess that more accurately, right? It was good. It worked to our advantage. I'm almost done. And then we added the 5th class, which was the seated person. It decreased the accuracy. So we lost a little bit of accuracy, especially on the first one that went down to 74%. It's still decent, but we lost the accuracy. So that's one of the things that this was the pilot. So we're quite happy with this. What we are going to do is that we're going to just do more tests and then see what will happen. So repeat that with a lot of people. And I just have one discussion point. One thing we learned was that the height of people was having an impact on that accuracy. And we do have a speculation on what happens. So with that discussion point, sorry, Mr. Chair, I misinterpreted the time availability, but this is my presentation. And I don't know if there is time for a question, but thank you very much.